So now we can see interpolation with equally spaced arguments or interpolation with equal intervals. Here there are two types. One is Newton forward interpolation, another one is Newton backward interpolation. So when can we apply this Newton forward interpolation means when the x is near the beginning of the table, we can apply it. If the x is near the end of the table, we can apply backward interpolation formula. Right? Now let us see the formula of it. Newton forward interpolation. Y is equal to y naught plus u by 1 factorial into delta y naught plus u into u minus 1 divided by 2 factorial into delta square y naught plus u into u minus 1 u minus 2 divided by 3 factorial into delta cube y naught plus u into u minus 1 u minus 2 u minus 3 divided by 4 factorial into delta power 4 y naught plus etc. It goes on. Okay, next we should know what is u. So where u equal to x minus x naught divided by h. This is the formula to find forward interpolation. Okay, next we can see Newton backward interpolation. Interpolation formula. Y is equal to yn plus v by 1 factorial into del yn plus v into v plus 1 divided by 2 factorial into del square yn plus v into v plus 1 v plus 2 divided by 3 factorial into del cube yn plus v into v plus 1 v plus 2 v plus 3 divided by 4 factorial into del power 4 yn plus etc. It goes on. Okay, so now we should know how can we find v. V is equal to x minus xn divided by h. Okay. Now let us see some problems based on Newton forward and backward interpolation. Newton forward interpolation formula. Let us see one problem in this. The population of a city in a census taken once in 10 years is given below. Estimate the population in the year 1955. Let us see the tabular column now. Year is given in the first row and population in the second row. You see the year given are 1951, 1961, 1971, 1981. Since the arguments are equally spaced, we can apply Newton interpolation formula. And the second row is population. The values are 35, 42, 58 and 84. Okay. Now go back to the question and see what is given. Estimate the population in the year 1955. Since the year 1955 is nearer to the beginning, that is nearer to 1951, we can apply Newton forward interpolation formula. Right? Let us see the solution now. Here, let us take x as X as year and Y as a population. And we know that Y is equal to f of x. Okay. Now we can write Newton forward interpolation formula. Newton forward interpolation formula. See, the formula starts with y is equal to f of x, which is equal to y naught plus u by 1 factorial into delta y naught plus u into u minus 1 divided by 2 factorial into delta square y naught plus u into u minus 1 u minus 2 divided by 3 factorial into delta cube y naught plus u into u minus 1, u minus 2, u minus 3 divided by 4 factorial into delta power 4 y naught. Okay, it goes on like this. This is Newton forward interpolation formula. Next, we have to find what is u, right? So, where u equal to x minus x naught divided by h, right? You know, x naught means the first value, the given first x value. The x value is, let us go back to the question now. You see, this is x naught, this is x1, this is x2, this is x3. Okay, so x naught is 1951. Here x naught equal to 1951 and h value is, you see what is the difference between x naught and x1? 10. 61 minus 1951 is 10. So h value is 10. And x value is given in the question, that is 1955. Okay. Take all the values and substitute it. U is equal to x value is 1955 minus x naught value is 1951 divided by h. So 1955 minus 1951 is 4 divided by 10. So you will get 0.4. Okay. After this, we can draw Newton forward difference table. Here x, y, delta square y, delta cube y. If you want, we can extend the table. See what are all the x values given: 1951, 1961, 1971, 1981. What are all the y values given? 35, 42, 58, 84. Okay. Now you have to see the difference between this 35 and 42. That is 42, from 42 you have to subtract. 42 minus 35 is 42 minus 35 is 7. Okay. Then 58 minus 42. What is the answer? 58 minus 42 is 16. Next, 84 minus 58 is 26. Okay, let us continue in the next column. You see, 16 minus 7 is 9, then 26 minus 16 is 10. Okay, next you see 10 minus 9 is 1. Okay, 10 minus 9 is 1. Right, now you have to take all the values like this. For forward interpolation formula, you have to concentrate on these values. Okay, so here y naught equal to 35, delta y naught equal to 7, delta square y naught equal to 9, and delta cube y naught equal to 1. Okay, let us make use of these values in the formula, right? Now we can substitute all these values in the formula. After substituting the values, we got 35 plus 2.8 minus 1.08 plus 0.064. If you add all the values, we will get 36.784. The next problem is, from the data given below, find the number of students whose weight is between 60 to 70. See the tabular column. The weight given are 0 to 40, 40 to 60, 60 to 80, 80 to 100 and 100 to 120. It is in continuous form. Therefore, we have to frame a cumulative table. And the number of students given in the second row are 250, 120, 100, 70 and 50. Right? Here, we have to apply Newton forward interpolation formula to find y when x lies between 60 to 70. Right? Let us see the solution part. Solution. Let x be the weight and y be the number of students. So here we have to apply Newton forward interpolation formula. The formula is y is equal to y naught plus u by 1 factorial into delta y naught plus u into u minus 1 divided by 2 factorial into delta square y naught plus u into u minus 1 u minus 2 divided by 3 factorial into delta cube y naught plus u into u minus 1 u minus 2 u minus 3 divided by 4 factorial into delta power 4 y naught plus etc. It goes on, right? In this we need u, so the formula to find u is where u equal to x minus x naught divided by h. Okay, here x naught is taken as 40 and x is taken as 70 and h value, the difference between each x value is taken as 20. Right, let us go back to the question and see. Here x naught is taken as 40 and the difference between each x value is 20. See, 20, and x value is taken as 70. Okay, for this we are going to apply Newton forward interpolation formula. See, next we have to frame the Newton forward difference table. Okay, So the Newton forward difference table should be drawn as, see here, x value should be written here and here y value, cumulative y, next delta y naught, delta square y naught, delta cube y naught, delta power 4 y naught. Okay, here x values, here y, here cumulative y, next delta y naught, delta square y naught, delta cube y naught, here delta power 4 y naught. Okay, next here below 40, below 60, below 80, below 100, below 120. Okay, and the y values given in the question are 250, 120, 100, 70 and 50. It is given in the question. Next we have to frame cumulative y. So how can we frame cumulative y? First you write 250 as it is. Next you add this 250 and this 120. You will get 370. Okay. Next if I add this 370 and 100, I will get 470. 470 plus 70 is 540. 540 plus 50 is 590. Okay. Next you see we have to find the difference. 370 minus 250 is 120. Next 470 minus 370 is 100. Next 540 minus 470 is 70. 590 minus 540 is 50. Okay. Next you have to find the difference between 100 and 120. This is minus 20. 70 minus 100 is minus 30. 50 minus 70 is minus 20. Okay. Next one is minus 30 minus of minus 20 is minus 10. Minus 20 minus of minus 30 is plus 10. Okay. And next 10 minus of minus 10 is 20. Okay. Like this you have to frame the tabular column. After this, since we are going to apply Newton forward interpolation, we have to concentrate on these values. See, y naught, delta y naught, this is y naught, this is delta y naught, this is delta square y naught, this is delta cube y naught, this is delta power 4 y naught. Okay. Now take all these values and substitute in the formula. Right. U is equal to x minus x naught divided by h. What is x value? X value is 70 minus x naught is 40 divided by 20. So we will get 30 by 20 which is equal to 1.5. Right. So u is taken as 1.5. Now we can substitute all the values in the Newton interpolation formula. That is 250 plus 1.5 into delta y naught is 120 plus 1.5 into 1.5 minus 1 divided by 2 factorial into minus 20 plus 1.5 into 1.5 minus 1, 1.5 minus 2 divided by 3 factorial into minus 10 plus 1.5 into 1.5 minus 1, 1.5 minus 2, 1.5 minus 3 divided by 4 factorial into 20. Okay, now you have to simplify this. If I solve this, I will get 250 plus 180 minus 7.5 plus 0.625 plus 0.46875. If I add all the values, I will get 423.59. Okay, 423.59, and approximately we can take it as y is equal to 424. Okay, so the number of students whose weight is 70. Number of students whose weight is 70 equal to 424. But I need the number of students whose weight is between 60 to 70. So what can we do? So the number of students whose weight is between 60 to 70 equal to, that is what you have to do, you have to subtract this 424 minus 370. Okay, so how can we do it? 424 minus 370. Let us go back to the tabular column. You see, in this below 60 cumulative value is 370. Okay, so we are subtracting this value from 424. So we will get the final value as 54. Okay, this is it. Now let us see Newton backward interpolation formula. The first problem is estimate the value of f of 84 from the following table. The x values are 40, 50, 60, 70, 80 and 90, and theta values are 184, 204, 226, 250, 276 and 304. Okay, let us see the solution part. Before that, we have to see the question. We estimate the value of f of 84 is given. Since 84 is nearer to the end of the value, we have to apply Newton backward interpolation formula, right? Let us see the solution part now. Solution, we can take, let y is equal to theta, right? Next, you see, since x is equal to 84 lies in the end of the table, we have to apply Newton backward interpolation formula. Now, Newton formula is as follows. So, y is equal to yn plus v by 1 factorial into del yn plus v into v plus 1 divided by 2 factorial into del square yn plus v into v plus 1 v plus 2 divided by 3 factorial into del cube yn plus v plus 1 v plus 2 v plus 3 divided by 4 factorial into del power 4 yn plus etc. It goes on. Okay, this is the formula for Newton backward interpolation. So here we need to find v. Okay, so how can we find v? Where V equal to x minus xn divided by h. Okay. So what is given? The x values are given. Let us go back to the question now. See, the x values, the interval between each x value, the interval between each x value was 10. So h is taken as a 10. Okay. Here h equal to 10. And what is the x value given? X is equal to 84. And xn, let us go back to the question once again. And which is xn? 90, right? Xn equal to 90. Okay. Therefore, V is equal to 84 minus 90 divided by 10. So, V is equal to minus 6 divided by 10 is equal to minus 0.6. Okay, V is equal to minus 0.6. Next, we can draw Newton backward difference table. X values, here y values, here delta y, delta square y and delta cube y, right? Next, let me fill the tabular column x, y, delta square y and this is delta cube y, right? What are all the x values given? 40, 50, 60, 60, 70, 80 and 90. Okay, next y values are 184, 204, 226, 250, 276, 304. Okay, now we can find the difference between these two values. 204 minus 184 is 20. Next, 226 minus 204 is 22. 250 minus 226 is 24. 276 minus 250 is 26. 304 minus 276 is 28. Okay, next. 22 minus 20 is 2. 24 minus 22 is 2. 26 minus 24 is 2. 28 minus 26 is 2. Next, you see, difference between these two is 0. Next also 0. Next also 0. Okay. Now, we got values to substitute it in the formula. So, what are all the values? For backward, we have to concentrate on these values. Okay. So, this is taken as yn. This is del yn. This is del square yn. This is del cube yn. Okay. So, next let us substitute it in the formula. Y is equal to 304 plus minus 0.6 into 28 plus minus 0.6 into minus 0.6 plus 1 divided by 2 factorial into 2 plus. That's all. Now we can simplify this. 304 minus 16.8 minus 0.24. Okay. So we will get 286.96. Approximately we can write 287 y value. Since we have taken y is equal to theta, so theta is equal to 287.